Yes, welcome back guys on India's largest e-learning platform, that is BYJU'S Exam Prep. And guys, this is the series going on for final board to BARC 2021, and today we are having the practice session for strength of materials. And guys, in this final board to BARC 2021, as you have seen already, the session have been there for different subjects, and today we are going to have the most important subject, that is strength of material. Hope everybody is ready for that. Yes, Rama Teja, good evening. So guys, we are starting the session. Just like and share the session at all other channels so that other student can also join us. And this is the detail about me. Today's subject is strength of material. Yes guys, let us move further. So guys, this is the very first question. We are starting with the easier one today, and then slowly we will be moving to the difficult questions. So this is the easier one. First of all, a bar of uniform cross section of 400 mm square is loaded as shown in the figure. The stress at section 11 is. So you need to find out the stress in this section 11. So you know it is very easy. Let us see how many of you give the right answer. Please solve it. Yes, please solve this question guys. Yes guys, what would be the answer for this one? Yes guys, yes, this is the question. Yes, Rama Teja, what would be the answer? You need to answer the stress at section 11. You know, if we call it bar 1, if we call it bar 2, if we call it bar 3. So my dear, if you want to write down the stress in member 11, it is going to be P11 upon A11. It is already mentioned that area is uniform throughout, and load you can see P11 is equals to minus 40 kilonewton. So when you are going to find out the stress in member 11, it is minus 40 into 10 power 3. This is the force, divided by area is equals to 400. So my dear, you will be getting the value of stress. Yes, very good Rama Teja, very good. The answer is going to be 100 Newton per mm square. I feel today the time of session have been changed. The students are not aware of that because this session was at 2 p.m. in the afternoon, but by chance as I came late, so this session was delayed and it is kept at 5 p.m. So this is the second question guys. Try to solve this question now. This is the second question. A composite bar means in parallel, is made up of steel and aluminium strips. Area of aluminium is 3 times the area of steel, where AA and AS are the areas of cross section of aluminium and steel bar. ES, and it is already mentioned, E of steel is equals to 3 times E of A. It is also mentioned. Due to an external load, the stress developed in the aluminium, it is mentioned that stress developed in the aluminium is 30 MPa. Then what is the stress developed in the steel bar? You need to find out the stress developed in the steel bar. This is what you need to find out. Yes, this is what you need to find out. What you need to find out. This is guys, you need to find out, and this is the case of bars in parallel. So let us see how many of you give the right answer. These are the options for you guys. Yes, quickly try to solve it. Composite bar means parallel, and you know that in parallel the elongations are going to remain same. So you will be saying the elongation in aluminium bar is equals to elongation in the steel bar. So elongation in the aluminium is going to be sigma aluminium, L aluminium and E aluminium. It is going to be sigma steel, L steel and E steel. So my dear, when you are going for this, now you need to solve it and get the answer. Yes guys, yes, please tell me what is the answer. You need to find out the steel, sigma steel. sigma steel. What is the answer? You can see, okay, one thing is mentioned, sigma aluminium is mentioned. Sigma aluminium is going to be 30 MPa. Okay, and when it is 30 MPa, you know sigma aluminium is P divided by area of aluminium. Area of aluminium, when we are going to talk about, area of aluminium is mentioned as 3 times the area of steel. So you can write it is 30 MPa and P is equals to 3 times the area of steel is equals to 30 MPa. So you know P by AS is the stress in steel bar. So stress in steel bar is 30 cross 3. It is going to be 90 MPa. Answer for this is going to be C, guys. Answer is going to be C, guys. This is how we can find out. Is it fine, guys? It is very easy question. It seems to be difficult. Okay, fine. We cannot use this because they have not mentioned the length. So we cannot use it. Question number 3, guys. So Ramadeja, I feel you got your mistake. This is question number 3. Okay, fine. Question number 3 is from SFD BMD. Guys, let us say this is A, this is B, this is C. So first of all, you need to find out the support reaction RB and support reaction RC. So you know how to find out this. You will write RB plus RC is equals to, this is mentioned that total W kilonewton is there. So this is total W kilonewton. This total load is W. So it is directly written as W. So when you will be solving it, you will be getting the value RB will be coming out to be 1.1 W and RC is coming out to be minus what you are getting. Are you getting it? Minus 0.1 W. And after getting this, you can see that this is UDL. Yes, anybody have answered or not? Fine, Dhye, very good. Dhye is saying answer to be A. Ankit Tripathi, okay, already have answered for the previous question. Rama Teja is already have said the answer to be A. Parvinder is also saying the answer to be A. Very good, guys. Wonderful. Wonderful going. So my dear, when you are going for this, you know this is UDL and 1 degree more than UDL is going to be inclined line. So if it is going to be inclined line, it is for sure true. Then RB will give you a jump. Yes, there is a jump of 1.1 W. It is there. And RC will be having a jump of 0.1 W. It is also there. And there is no load in between. So it will be a horizontal line. So answer is going to be A for sure. This is how we are going to show. Yes, Manipal, Parvinder, very good, guys. This is how we are going to solve. So my dear, let us move to the next question. In this, bending moment equation is given and you need to find out where the shear force is going to be 0. I would like to tell you that dm by dx is equals to shear force. So you need to find out where the shear force is 0. Is it fine, guys? Yes, guys. You can solve it. Yes, guys. Very good. Dhye, Parvinder. Very good, guys. Very good, guys. Vaughn, very good, very good. So guys, bending moment is A x minus x cube by L square. So my dear, you know dm by dx. When you will be finding out, differentiation of x will be 1 minus 3x square upon L square. So when you will be putting dm by dx to be equals to 0. So you know this is shear force 0. So you will get x is equals to L by root 3 plus minus. C will be the answer. C will be the answer. Is it fine, guys? So many of you have already given the answer. Rama Teja, Manipal, Ankit Tripathi, Von, Parvinder, Dhey. Very good, guys. Question number 5. This is also a famous question, and why I have taken this? Because this type of question are coming directly in the exam many times. Okay, so when they are coming directly, we shall not leave them. You might have seen this question before. Even I have taken 2 to 3 times in the classes, that a cantilever beam AB of the triangular section has length of L, base width of B and height of H. The beam made up of brass having unit weight of gamma kilonewton per meter cube. Yes. So my dear, you can see this to be a triangle. So you know, if centroid we are going to say here, this distance is going to be 2h by 3. This distance is h by 3. So when this distance is 2h by 3, this is h by 3, you need to find out the maximum tensile stress. You know, due to load, obviously the beam is going to deviate like this, which is going to be hogging moment. So when it is going to be the hogging moment, then obviously tension will be coming on the top fiber. First of all, you need to find out if you can assume due to self weight only, so you can assume it to be a UDL loading, and UDL will be of W kilonewton per meter. We can find out this W when this gamma is kilonewton per meter cube. When this gamma will be multiplied with the area, it will become kilonewton per meter. So gamma into area is BH by 2. Gamma into BH by 2. Okay, guys. So this is gamma into A, gamma BH by 2. So my dear, when we are going to say this, this will be having a unit of kilonewton per meter. So if this is having W, kilonewton per meter is the loading, then my dear, you know, when you will be finding out the maximum bending moment, it is going to be equals to minus WL square by 2. So W is nothing but gamma BH by 2, gamma BH by 2 into L square by 2. So this is maximum bending moment. Yes, very good, guys. I feel some of you are trying it. Then my dear, after getting maximum bending moment, you can find out the maximum tensile stress is going to be M maximum. Distance is going to be H by 3 for the top fiber. It is, then you will be putting it here INA, that is BH cube upon 36. This will give you the value of tensile stress. What you are getting it, guys? क्या रहा है? Self weight is assumed to be UDL only. Self weight is assumed to be UDL only. What will be the answer, guys? Yes, guys. Parvinder is saying answer to be B. And yes, Rama Teja is also saying B. Manipal is also saying B. And guys, yes, answer is going to be B only. 3 gamma L square upon H. Okay, guys. 3 gamma L square upon H. Next is a rectangular beam 10 cm wide is subjected to a maximum shear force of 50,000 Newton. The corresponding maximum shear stress being 3 Newton per mm square. You need to find out the depth of beam. Okay. So you know that tau maximum can be written as SAY bar upon INAB. But that kind of data is not given. This is not tau maximum. This is tau at any fiber. Tau maximum is 3 by 2. Sorry, it is a rectangular beam. So it is 3 by 2 tau average. And 3 by 2 tau average is force but a area. It is width into depth. So this is already mentioned as 3 Newton per mm square. So as is already mentioned, you need to find out the depth. सर अगर मैक्सिमम मैक्सिमम नॉर्मल होता तो 2h/3 करते. मणिपाल हमने इसलिए किया, वी हैव मल्टीप्लाइड इट विद द क्रॉस सेक्शन बिकॉज UDL is W kilonewton per meter. So when kilonewton per meter cube is there, so you need to multiply it with the area to get it into kilonewton per meter. Okay, Dhey is saying A, Parvinder is saying A, Spiderman is saying A, Manipal is saying A, Rama Teja is saying A, and when you will be finding out, you will be getting the answer to be 25 centimeters only. A would be the right answer. Wonderful, guys. Wonderful. Now you got it, Manipal. Fine. Question number 8. My dear, now it is from theory of failure. The limit of proportionality. The limit of proportionality of a certain steel sample is 300 MPa. So my dear, SYT is 300 MPa. In a simple tension, it is subjected to principal stresses of 150 MPa. Sigma 1 is 150 MPa. 60 MPa tensile is sigma 2. Sigma 3 is 30 MPa. According to the maximum principal stress theory, the factor of safety in this case would be, my dear, you know, when you will be going for MPST, then sigma max under combined loading is less than equals to sigma max under tension test. So it is 150 less than equals to, it is going to be 300 divided by factor of safety. I feel all of you have got it. Parvinder have got it, Rama Teja have got it, Pranav have got it, Dhey Mehta has got it, Manipal got it. The answer is going to be 2, guys. Okay, yes, this is the answer. Okay, if I say you need to use MSST, then what you will be getting the answer? If I say use MSST, then what will be the answer? For MSST, what will be the answer, guys? For MSST, what would be the answer? For MSST, maximum is going to be sigma 1 minus sigma 3. 150 minus 30 is less than equals to 300 by n. So n will be 300 by 120. Then 2.5 would be the answer. Very good, guys. Wonderful. Very good, Parvinder. Fine. Next question. So guys, today we are doing only strength of material. Machine design we will be covering with Tom. Okay. Yes, as actually this session was at 2 PM, I delayed it at 11 PM. So that's why today I have taken only SOM. MD we will be covering with Tom because it is a late night session now. Yes. So guys, will it be okay if we continue the mechanics part also at this time? Will you be able to come? Yes, Spiderman. For MSST it will be 130 or 300 by 120. Yes, for sure. In a two-dimensional stress system, two principal stresses are sigma 1 is 180 Newton per mm square and sigma 2 is not mentioned, minus sigma. (180) sigma 2 is not given here ना. हाँ मणिपाल, एब्सोल्यूट ही तो लिया MSST में, वहां पर एब्सोल्यूट ही तो लिया. सिग्मा 1 माइनस सिग्मा 3 वाज द मैक्सिमम ना. If you find out sigma 1 minus sigma 2, sigma 2 minus sigma 3, sigma 1 minus sigma 3, that is how we have done. I am showing you. If you see, sigma 1 is 150, sigma 2 is 60, sigma 3 is 30. Maximum will be sigma 1 minus sigma 3 only. Okay. Yes. Next question may yes, you need to find out sigma 2 according to maximum normal strain theory. Means you need to go by Saint-Venant theory. Saint-Venant theory. Dear, you will find out first of all for epsilon 1 less than equals to SYT upon E. Epsilon 1 is sigma 1 upon E minus sigma 2 upon E. Mu less than equals to SYT upon NE. Factor of safety need not to consider. You will be getting, take N as 1, EE will get cancel out. So from here you can find out the value of sigma 2. You will be getting the sigma 2 from epsilon 1 as you will be getting 240. I feel you will be getting 240 MPa. And my dear, then you will be checking for the second case. It is if you are going to go for minus sigma 2 upon E minus mu times sigma 1 upon E. This is epsilon 2 less than equals to SYT upon E. So when you are going for this less than equals to SYT upon E, EE will get cancelled out. So my dear, here you will get sigma 2 to be less than equals to 195 Newton per mm square. Is it fine? So my dear, one side he is saying less than 240, other side he is saying less than 195. So my dear, the answer is not going to be 240, answer is going to be 195. Okay, because both the condition must satisfy. Guys, please like and share the session as well. I feel we are doing some wonderful question. Yes or no? Okay, so this is a wonderful one. This is a different question. Okay, something of new type. Next question, guys. According to maximum shear stress failure criteria, yielding in material occurs when maximum shear stress is half of yield stress, maximum shear stress is root 2 times of yield stress, maximum shear stress is root 3 times of yield stress, maximum shear stress is 2 times of yield stress. So what you will be getting as the answer? Yes. So according to maximum shear stress is, according to maximum shear stress, you know that. According to MSST, SYS is 0.5 times of SYT. According to MPST, SYS is equals to SYT. MSCT, you will get it in terms of mu. MDET, 0.577 times of SYT. So for answer it is going to be A. Is it fine for everyone, guys? Are you getting it? Great. Now we are going to some very good question. Question number 11. If n is the ratio of internal and external diameter of the hollow shaft, you can say when di by do is going to be n, whatever we were assuming it to be k, it is n here. The ratio of the weight of hollow shaft to the weight of solid shaft. And solid shaft, in order to have the same strength, okay, in order to have the same strength, they have mentioned the same strength. So you need to find out this. So they are saying same strength. Same strength means Z of hollow is equal to Z of solid. Z of hollow is pi by 16. It is going to be d naught 4 minus di 4 upon d naught. And Z of solid is pi by 16 ds cube. So pi by 16 will get cancel out. D naught cube 1 minus n4 is equals to ds cube. This is one. Solve it, guys. I won't answer from your side. Yes, here it is correct only. But as I said, I have not written because we need to answer only for one. Yes, good evening, Sonali. Yes, so find out, guys, what will be the answer for this one. So you can find out from here ds by d naught. It is 1 minus n4 1 by 3. Okay, yes, this is how you will be getting. So after that you need to find out WH by WS. It is going to be gamma AHL gamma ASL. So gamma will get cancel out, length will get cancel out. You will get WH upon WS as area of hollow to the area of solid. And you know that area of hollow is pi by 4 d naught square minus di square pi by 4 ds square. Very good, Parvinder, very good. So Parvinder have got the answer to be B. When you will be putting this value, you will be putting ds by d naught as well. You know, you will be getting the answer to be 1 minus n square 1 minus n4 by 2 by 3. This is weight of hollow to the weight of solid. Very good, guys. Wonderful, guys. So this is how you can find out the answer to this question. Very good, guys. Wonderful. So let us move to the next question. Now this is a question from deflection. My dear, load is acting at point C and point D. You need to answer the slope at A. So my dear, I am going to help you for that. If you want to go for moment area method, my dear, I am going to give you the bending moment diagram. So you can easily use the moment area method. So my dear, this is going to be the BMD for this. For C to D, bending moment is going to be constant, and if you find out the reaction by symmetry, it is coming out to be P, it is coming out to be P only. So at a distance of L by 3, you will be having this value to be PL by 3, and this is also PL by 3. Okay, this is going to be bending moment diagram. Solve it. You need to find out the slope at A. You know deflection will be maximum at E. Okay. So this is going to be PL by 3, PL by 3. Solve it. If you will try to solve it, you will get theta at E minus theta at A. Area of triangle and rectangle. Area of triangle is half. First of all, take 1 upon EI outside. Area of triangle is half PL by 3 into L by 3 plus area of rectangle is PL by 3 into this distance is L by 2 minus L by 3. So you will be getting minus of theta at A 1 upon EI PL square upon 18 plus PL upon 3 L upon 6. So my dear, you will get PL square upon 9EI. Minus means clockwise. Dear, answer is going to be A. Why no option is matching? Manipal, answer is going to be A. Very good Parvinder, Arun, very good Dhye, Ramateja, very good guys. A option is correct one. Wonderful guys, बहुत ही बढ़िया शानदार. एक और क्वेश्चन हो जाए डिफ्लेक्शन से. Let us have one more question from deflection guys, and quickly like and share the session as well. Let's have one more question. This is once again from deflection. This time you need to go for the strain energy method. Slightly lengthy question guys. Very good Spiderman, Ankit Tripathi, Rama Teja, Dhye. Wonderful guys. So we will solve it and get the answer. Surya Singh, very good. Very good. So first of all, you will be finding out the support reaction. This is support reaction RA, RB. RA plus RB is equals to P. You will be going for summation moment about A to be 0. P into 4L by 3 is equals to RB into L. So RB is 4P by 3. RA is minus P by 3. Is it fine guys? These are the support reactions, and now you need to find out the strain energy of the beam. Strain energy of the beam is U of AB plus U of BC, and U of AB is going to be M11 square dx upon 2EI. BC is upon 2EI. So my dear, one section you will be taking here. One section you will be taking here. So you will be taking RA. This is going to make RA into X. Okay. So UAB will be 0 to L. UAB will be 0 to L. It is going to be guys RA into X. RA is value RA is minus P by 3. So minus P by 3 into X ka square dx upon 2EI. You need to solve it. And U of BC, when you will be finding out, it is going to be integration of 0 to, this is going to create hogging moment. P into L by 3. Minus P into L by 3 dx upon 2EI. You need to solve these, and after getting the total strain energy, you will be saying that D of U total divided by D of P will give you deflection at C. So you need to find it now. Yes, Rama Teja, very good. Parvinder, very good. Wonderful, guys. And the answer you will be getting is correct. C is correct. Parvinder, very good. Rama Teja, very good. You will be getting the answer to be 4PL cube upon 81 EI. Just need to put the values, nothing more than that. Sure, Spider-Man, we will do that. We will surely do that. Thanks for your wonderful words. Is it fine? Very good. So guys, with this we have completed the SOM question for today for this session. Okay. So machine design we will be having with the TOM. This session was small only because as time was changed, so I didn't put much more question, but I feel you got some good feeling about the questions. And one thing you need to learn, when you find this type of question, you always try to skip them in the starting and do them in the last. Do not do these questions in the starting because they will be wasting your time. I am talking when you are going for the BARC examination. Hope you guys got this. And guys, tomorrow at 5 PM we are going to meet on BYJU'S Exam Prep app. Tomorrow I will be taking the session on the wedges and we will see some problems on the wedges. Wedges is a very important topic because it is a newly added one. Okay, and after that we are going to see belt and pulley friction as well. And I am sharing previous year's gate question of mechanics in the Telegram channel as well. Yes, this PDF I am sharing. Yes, Rama Teja, it is time consuming, but we need to learn it. परविंदर, इंजीनियरिंग मैकेनिक्स मैंने इस बार किसी भी बैच में नहीं पढ़ाई क्योंकि इस बार मैंने सिर्फ सोम, टॉम और प्रोडक्शन का एक पार्टी लिया है. रीजन बीइंग द बैचेस आर मोर, क्योंकि अब हिंदी बैचेस भी हैं. पहले सिर्फ इंग्लिश होते थे और एज नाउ देयर आर हिंदी बैचेस. So this time I didn't get the time, but last year I have taken SOM, TOM, MD, Industrial Production, Mechanics, all these subjects. Okay? Yes. Last time I have taken 7 subjects. This time batches are more, so I am taking only SOM, TOM, MD majorly. MD also now I will be taking. Okay? So because of less time only. But yes, surely I will be completing engineering mechanics in the YouTube and app. So don't worry about that. Okay? So we are going to have everything, whatever could be in the paid courses. You just join me regularly. You will get engineering mechanics in the similar fashion what you have with other subject. Okay? Don't worry, Parvinder. Okay, guys. So let us meet tomorrow 5 PM for wedges. Okay? In the engineering mechanics series on the app. Yes. Thanks, Parvinder. So goodbye guys for all of you. I'm sharing the PDF in the Telegram channel.